Welcome to Part 4 of Advanced SQL. Master complex inner, left, and cross joins, subqueries, CTEs, and loading views with real business case studies.
Direct, urgent tone. Passing a data engineering interview at a global marketplace like Airbnb or Amazon requires proving you can build a production-grade pipeline. A simple select statement won't cut it. This chart shows the foundational join types. We are assuming you already know how to combine datasets using an equijoin, a non-equijoin, and outer joins like left, right, and full. But real-world business logic rarely fits perfectly into those standard relational models. You will face messy, overlapping cohorts, late-arriving events, and hierarchical structures that force you to pull out a much more advanced toolkit. Mastering that advanced toolkit is the exact dividing line between a junior rejection and a senior-level offer. Sometimes you need to link tables without standard foreign keys, which is where a cross-join generates every possible combination. Other times, you need to query hierarchies within a single table, like mapping employees to their managers, requiring a self-join to match a table against itself. Union all stacks query outputs instantly, while union triggers an expensive sort to remove duplicates. For overlapping cohorts, don't use OR, it returns users in either group. Instead, use INTERSECT to strictly find users existing in both sets. Execution matters. Standard subqueries resolve once, passing a static value. Correlated subqueries loop, retabulating against every row. Next, beware the not in clause. A single null makes the entire filter fail as unknown. Instead, use not exists, which safely checks for a record's presence. Writing advanced SQL requires you to anticipate these exact query engine bottlenecks and handle fatal edge cases like null semantics before they break production. As logic scales, queries become unreadable. Common table expressions, or CTEs, structure your code by turning chaotic, deeply indented nested subqueries into a clean, linear sequence of labeled, modular blocks. This modularity enables recursion. A recursive CTE has two halves. The anchor element establishes the base, like finding the CEO. The recursive member then loops to pull in direct reports, cascading downwards until the org chart is mapped. Let's test this. Imagine bookings and hosts tables. Calculate the host fill rate for only their first 90 days, using a CTE for night grain expansion and an exists clause for cancellations. Pause the video here to map out your logic. CTEs provide a procedural flow for your SQL, allowing you to sequence logic step by step to capture complex marketplace dynamics. Beyond the script itself, you have to deploy the logic. A standard view calculates the underlying query on the fly every time it's referenced. A materialized view stores a physical copy of the result set, saving massive compute time for complex aggregations that only need periodic updates. For intermediate processing during a script run, you'll use temporary tables. You must specify their persistence. Session-level temporary tables hold data until you disconnect, while transaction-level tables clear their rows the moment a commit occurs. Finally, to wrap, automate, and schedule these massive scripts, you build stored procedures. These allow you to pass dynamic input parameters and execute complex procedural logic on a recurring schedule. Flawless syntax won't pass a system design round if you can't articulate interactions with physical server memory, automated scheduled jobs, and the core database architecture. You have navigated data grain expansion, execution traps, and physical production deployments. Here are the 4 rules to take with you. Default to union all over union. Use INTERSECT for dual cohort membership. Prefer not exists over not in to avoid null failures. And build your logic sequentially with CTEs. Applying these 4 architectural patterns provides the technical foundation needed to navigate the complexity of senior-level data engineering interviews.
Start thinking like data professionals. Subscribe to Data Hacks Daily by RS for the next part. Keep learning. See you in the next video.